So in this video, I'll be covering some information useful about inductors for the physics GRE. An inductor is typically a coil of wires, such as a solenoid, which is why their picture in circuit diagrams is as such. So the voltage across an inductor is equal to L di dt. So L is the inductance of the inductor, and di dt is the time derivative of the current in the circuit. So much like capacitors, inductors can store energy in them, and their stored energy is equal to 1/2 Li squared, so 1/2 the inductance times the current squared. You'll note how this form is pretty similar to the energy stored in a capacitor, which you can recall as 1/2 Cv squared, so just replace C by L and V by I to get this. If two inductors are in parallel, the equivalent inductance can be found by noting that the inverse of the equivalent inductance is equal to the sum of the inverses of the individual inductances. And more simply, if the inductors are in series, the equivalent inductance is just the sum of the individual inductors. So you'll note how these are the same rules that are used for resistors. And finally, if you have an inductor in a circuit that originally has no current flowing through it or no like battery attached or anything, but then you flip a switch to turn the current on and to activate the circuit, say, the voltage across an inductor over time will follow this trend here. So this makes sense because when the circuit just turns on, the current goes from 0 to some value, so di dt will be very large, and thus the voltage across the inductor will be very large. However, you can think of as time goes on, the current in the circuit will sort of stabilize, making di dt go to 0, and that's why the voltage is also going to 0 as t continues to increase. So I hope that you enjoyed this video, and if you have any questions, comments, or suggestions, please leave them below. Thank you.